Subtopic 6.3 Partial Fractions. Two or more proper fractions can be combined to give a single fraction. For example, 1 over 3 plus 2 over 5 is equal to 11 over 15. Or 3 over x minus 2 over x minus 2 is equal to x minus 6 over x times in bracket x minus 2. Equally, a single proper fraction can be expressed as a sum or difference of two or more algebraic fractions. For example, 11 over 15 is equal to 1 over 3 plus 2 over 5. 1 over 3 and 2 over 5 are known as partial fractions of 11 over 15. Okay, example number 2, x minus 6 over x times in bracket x minus 2 is equal to 3 over x minus 2 over x minus 2. In this case, 3 over x minus 2 over x minus 2 are known as partial fractions of x minus 6 over x times x minus 2. Okay, types of fractions. We call a fraction is a proper fraction when the degree of the numerator is less than the degree of the denominator. For example, 3 over 5x, x squared over x power 3 plus 1, or 2x squared minus 7 over x power 3 plus 1. Whereas, a fraction is an improper fraction when the degree of the numerator is greater than or equal to the degree of denominator. For example, 5 over 3, 2x power 4 minus 7 over x power 3 plus 1, or 3x power 3 plus 7 over 2x power 3 plus 5. Definition: a fraction can be expressed or decomposed as the sum of two or more proper fractions. This is known as partial fractions. Okay, which is bx over qx is equal to ax over bx plus cx over dx plus ex over fx. All of these we call it as partial fractions. Okay, we move to the last part, partial fractions. Let's look. The first one is proper fractions. Okay, for proper fraction, actually we have three types of denominator. Okay, the first type is denominator with distinct linear factors. The second type is denominator with repeated linear factors. And the third type is denominator with quadratic factors. Okay, if qx is a product of linear factors, okay, thus bx over a1x plus b1 times a2x plus b2 times times arx plus br can be expressed as capital A1 over a1x plus b1 plus capital A2 over a2x plus b2 plus until plus capital AR over ARX plus BR, whereas A1, A2 until AR are constant. Okay, let's look how can we split the given proper fraction into partial fraction. Okay, for example here we are given the left hand side is x plus 5 over x minus 4 times x plus 6. Okay, so to split into partial fraction, okay, this is linear. X minus 4 is linear factor. So to split, it should be, the numerator is constant. Numerator for linear factor here should be constant. Okay, the second factor also linear. So it should be constant. We denoted as b. Okay, so x plus 5 over x minus 4 times x plus 6 is equal to a over x minus 4 plus b over x plus 6. Alright, okay. Second example, let's say we have 7x minus 4 over x plus 3 times x minus 5. So both factors here are linear factor. So to split into partial fraction, it should be a over x plus 3 plus b over x minus 5. Okay, let's see, we have the third example. Let's say we have for x over x plus 1, x plus 2, and then we have here 3 minus x. Okay, this is proper fraction. So how can we split into partial fraction? Okay, to split into partial fraction, firstly we need to determine types of denominator. Okay, here we have the first factor is linear. So if linear, numerator should be constant. So a over x plus 1. Okay, second factor also linear. So it should be constant also. So b over x plus 2. And the third factor here, 3 minus x also constant. So it should be c over 3 minus x. And then we will proceed with the procedure to find the value of a, b, c. Okay, and then substitute back the value a, b, c. We can have the final answer for for partial fraction on the right hand side. Okay, let's see this example. Okay, express 2x minus 3 over x plus 1 times 3x plus 2 in partial fractions. Okay, so we are given. Okay, we are given 2x minus 3 over x plus 1 times 3x plus 2. Okay, firstly, we need to split into partial fractions in terms of a, b, and c. Okay, okay, here we have two factors. Okay, let's check the types of denominator. The first factors are linear, so if we want to split into partial fraction, it should be a over x plus 1. Okay, plus, okay, second factor also linear, so it should be constant on the numerator. So b over 3x plus 2. Okay, from here, this is our first step. Okay, second step, we need to equating denominator. Okay, our denominator on the right hand side should be equivalent to denominator on the left hand side. Okay, from here, if we check, okay, a already have the denominator of x plus 1 here. So, it does not have 3x plus 2, means a must multiply with 3x plus 2. Okay, b already have 3x plus 2, but still does not have x plus 1. So, b must multiply with x plus 1. Okay, the whole thing, now we'll have the same denominator with the left hand side. Okay, next we need the equating numerator. Okay, so equating numerator, we will have here 2x minus 3 is equal to a times 3x plus 2 plus b times x plus 1. Okay, from here, we need to find the value of a and b. Okay, let's say we use the method of substituting method. Okay, okay, let's say x equal to negative 1. Okay, why I choose x equal to negative 1? Okay, because when we substitute here x equal to negative 1, b negative 1 plus 1 is 0, so 0 times b is 0, so we can find the value of a. So substitute, we have here 2 times negative. So substitute, we have here 2 times negative 1 minus 3 is equal to a times 3 times negative 1 plus 2. Okay, and here plus 0. Okay, because negative 1 plus 1 is 0, 0 times b is 0. Okay, we can find the value of a here. Okay, so negative 2 minus 3 is negative 5 is equal to negative 3 plus 2 is negative a, right? So a is equal to 5. Okay, next substitute the other value so that we can find the value of b. Okay, for example, okay, let's say we substitute x equal to 0 into this equation. So we will have here negative 3. Okay, negative 3 is equal to a times 2 plus b times 1. Okay, a we know the value is 5. So 5 times 2 plus b. Can we find what is b? B is equal to negative 13. So from here we need to rewrite back. Okay, substitute back the value of a and b into the partial fraction. Okay, step number 1 we already done before. What is the value of a and what is the value of b to find the final answer. Okay, therefore our final answer will be 2x minus 3 over x plus 1 times 3x plus 2. Okay, and this is equal to a. What is a? A is 5 over x plus 1 and b is negative 13. So negative 13 over 3x plus 2. Okay, this is our final answer for partial fraction of the given expression. Okay, let's see the second example. Okay, we can express 5x plus 1 over x times x plus 1 times 2x minus 1 in partial fractions. Okay, so firstly, we need to split into partial fraction. Okay, check the types of denominator we have here. Okay, the first factor here is linear. Actually, all the factors given are linear, right? This is x power 1, this is also x power 1, this is also x power 1. So, to split into partial fraction, it should be, okay, the first one is a over x plus, okay, b over x plus 1, okay, because the denominator here is linear, and plus c over 2x minus 1. Okay, this is our first step. Okay, next we want to equating. Second step is equating denominator. Okay, remember our denominator on the right hand side should be equal to denominator of the left hand side. Okay, check. Okay, which one we already have and which one we still do not have. To equating denominator, okay, okay, a we only have x here. Okay, x here we still do not have x plus 1 and 2x minus 1. So a here we need to multiply with x plus 1 and 2x minus 1. Okay, plus b. Okay, b. We only have here x plus 1 only. So there are other two factors. Okay, we need to multiply with b. And c we need to multiply with x and x plus 1. Okay, all we divide by x times x plus 1 to x minus 1. Okay, third step is equating numerator. So our numerator on the left hand side is 5x plus 1 and numerator on the right hand side. Okay, equating. So we have here 5x plus 1 okay, is equal to a times x plus 1 times 2x minus 1, okay, plus b times x times 2x minus 1 plus c times x plus 1. Okay, we proceed with the procedure with substituting the value to find the value of a, b and c. Okay, let's say firstly we substitute, okay, what number? Okay, here to make it a0, we can substitute x with negative 1, right? Because negative 1 plus 1 is 0. So, okay, and then here if x is negative 1, so c also 0. Then we can find the value of b. Okay, so let's substitute x equal to negative 1. Okay, so here we have 5 times negative 1 plus 1 is equal to, here is 0, right? So I put here 0 plus b times negative 1 times 2 times negative 1 minus 1. C, if we substitute x with negative 1, here we have 0, so plus 0. So simplify, we have here negative 6 plus 1 is negative 4 is equal to, so what is b? Here we have 3b, right? So we can find the value of b. What is b? So b is equal to negative 4 over 3. Okay, next, let's proceed to find the value of a and c. We already have the value of b. Okay, if we check here, if we substitute x with 0, c is 0, right? b also 0. Then we can find value of a. So let's substitute x is equal to 0. Then when x is 0, okay, so substitute into the equation of numerator. We will have here when x is 0, the right hand side is 1 is equal to a times 1 times negative 1, right? Plus, okay, when x 0, so all of this is 0, c also 0, so plus 0 plus 0. Then we will have here the value of a is negative 1. Okay, let's proceed to find the value of c. Okay, to find the value of c, okay, we can make it a value of b and a0. Okay, to make it a0, we need to substitute x is 1 over 2. Okay, just take here, okay, 2x plus 1 is equal to, 2x minus 1. Okay, let x is equal to 1 over 2. Okay, substitute into the equation of numerator here. Then we will have, okay, 5 times 1 over 5 times 1 over 2 plus 1 is equal, okay, here if we substitute x with 1 over 2, then a is 0. Okay, so plus 0 plus, okay, here also when we substitute x is 1 over 2, then we will have b is 0, so plus 0, and c plus c, okay, x is 1 over 2 times 1 over 2 plus 1. Okay, can you find what is the value of c? Okay, on the left hand side we have 5 over 2 plus 1 is 7 over 2, right? On the right hand side is c times 1 over 2 times 3 over 2. Okay, so we have here 3 over 4 c. 3c over 4 is equal to 7 over 2. So what is c? C is equal to 4 over 3 times 7 over 2. So we can simplify. We have here c is 14 over 3. Okay, so we already have the value of A, B and C. Don't forget to substitute back the value of A, B and C into the partial fraction. So our final answer should be, okay, 5x plus 1 over x times x plus 1 times 2x minus 1. Okay, equal to, okay, just now we split it become A over x plus B over x plus 1 plus C over 2x minus 1. Okay, so just substitute back what is the value of A, B and C. Value A is negative 1, so it will be negative 1 over x. Okay, what is B? B is negative 4 over 3, so negative 4 over 3. Okay, so 3 times with x plus 1. Okay, please beware how we can write the correct answer. And C is 14 over 3, so plus 14 over 3. Okay, times in bracket to x minus 1. So this is our final answer.